So, what does it really mean to understand something? It sounds like a pretty simple question, doesn't it? But honestly, it's a puzzle that has kept philosophers up at night for centuries. And right now, it's at the absolute heart of the whole debate around artificial intelligence.
All right, so let's just dive right in. I want you to really think about this for a second. It's kind of like a riddle, right? We use the word understand all the time, every single day. But trying to pin down what's actually going on in our minds when we grasp a concept, well, that's where things get really interesting.
And this right here illustrates the core of the issue perfectly. On one side, you've got rote knowledge, just memorizing and recalling facts. You can spit back the textbook definition of photosynthesis, no problem. But on the other side, you've got deep understanding. Can you actually explain it to a kid? Can you come up with an analogy? That is a whole different ballgame. And that's exactly what we're going to unpack today. Okay, so to really get to the bottom of this, we've got to start with philosophy. Because a long time ago, thinkers started seeing understanding not as just some mental trick, but as something absolutely fundamental to how we exist in the world. This idea, which comes from a corner of philosophy called hermeneutics, which is basically the study of interpretation, is a total game changer. It says that understanding isn't something you do, it's how you are. It's our basic way of being. It's how we feel at home in the world, you know? It's the constant background process that gives meaning to everything else. So how does this actually happen? Well, the philosopher Hans-Georg Gadamer gave us this really beautiful concept called the fusion of horizons. Think of your own perspective. Everything you know, your culture, your personal history, as your horizon. It's the limit of what you can see. Understanding happens when your horizon meets and merges with someone else's, maybe from a book or a different culture. And here's the cool part. Neither horizon just takes over. They fuse together to create a brand new, bigger, shared understanding. And this table just shows you how massive a shift this was. See, the old way of thinking, classical epistemology, treated knowledge like it was a science experiment. You're supposed to be a detached, unbiased observer just collecting objective facts. But hermeneutics comes along and says, no way, you can't be detached. You're always an active participant. And your personal history, your biases, what Gadamer called your prejudices, they aren't a flaw to be eliminated. They're the very starting point for understanding anything at all. All right, so that's the big kind of heady philosophical picture, but what's actually happening inside our heads? Let's switch gears and jump into cognitive science to see how our minds actually build these structures of meaning. So the first key idea here is something called a schema. The easiest way to think about schemas is like the mind's filing cabinets. They're these stable mental templates for, well, everything you know. You've got a schema for dog, a schema for going to a restaurant, a schema for a birthday party. They help you organize new information fast and even fill in the blanks with some default assumptions. But see, schemas are just the building blocks. To really understand something new or complex, you build what's called a mental model. This is like the mind's own dynamic simulator. It's a little small-scale model of reality that you build on the fly, using parts from your schemas so you can run simulations, figure out how things work, and predict what's going to happen next. So let's just nail this down, because it's super important. Schemas are like the encyclopedia in your head. They're stable, long-term knowledge. Mental models are the flight simulators you build in your head for a specific problem. You pull information from those stable schemas to build these flexible, on-the-fly mental models. And that's how we are able to deal with brand new and totally unfamiliar situations. Okay, let's go even deeper. We've gone from philosophy to the mind's software. Now we're going down to the brain's physical hardware. I mean, how do billions of tiny neurons actually create something as profound as meaning? You know, it really all boils down to this one famous principle in neuroscience. Neurons that fire together, wire together. Think about an apple. When you experience one, the neurons for its round shape, its red color, its sweet taste, and even the motor action of biting it all fire at the exact same time. The more that happens, the stronger those connections get, until they're literally wired together into a network. That network is the physical representation of the concept apple in your brain. But here's the magic, right? The brain doesn't just store data like a hard drive. It weaves this incredibly rich tapestry of meaning. Just think about it. It links words to real-world feelings and actions. It combines ideas to invent totally new ones. It tags everything with emotion. Is this good for me or is it a threat? And it even creates abstract symbols for things like justice or mathematics. This is the alchemy that turns raw information into genuine meaning. So, all of this, the philosophy, the psychology, the neuroscience, it's all been leading up to this. The elephant in the room, the biggest question of our time. We are building machines that are just unbelievable at processing information. But can they ever truly understand? To really wrestle with this, we have to talk about one of the most famous thought experiments in the history of philosophy, John Searle's Chinese room. It is a powerful and, pretty controversial argument that throws a huge wrench in the idea that a machine could ever really think. Okay, before we actually step inside the room, we need to get this distinction down cold. Syntax is all about rules. It's the grammar of a language, the formal process of shuffling symbols around. Semantics, on the other hand, is about meaning, what those symbols are actually about, what they refer to in the real world. And that difference, it's everything. All right, let's break down Searle's argument step by step. First, what is a computer program really? At its most basic level, it's just a set of formal rules. It's pure syntax. It's a rule book for manipulating symbols with absolutely zero awareness of what any of those symbols actually mean. Okay, second piece of the puzzle, the human mind. When we think, it's not just about following rules. We have actual mental content, beliefs, hopes, desires. We have semantics. The words we use are attached to real meaning, to real experience. Now, here's the absolute linchpin of the whole argument. Syntax, by itself, can never ever create semantics. Searle's big point is that no matter how incredibly good you get at shuffling symbols according to a rulebook, that act of shuffling will never magically blossom into genuine understanding. And this leads to a pretty stunning conclusion. Since computer programs are just syntax, and minds are full of semantics, then a computer program can never actually be a mind. A machine, Searle argues, might create a perfect simulation of understanding, but it will never, ever duplicate the real thing. This classic philosophical argument is more relevant today than ever. In fact, some of the sharpest critics of today's large language models use a very similar idea, calling them stochastic parrots. Stochastic just means based on probability. They're basically arguing that these AIs are just super sophisticated parrots, mindlessly predicting the next most statistically likely word without any real understanding of what it all means. So after all that, what's the takeaway? What makes human understanding so, human? When you put it all together, it looks totally different from pure computation. Our understanding is grounded in our biological need to survive. It's flexible and transferable, letting us solve new problems. And maybe most importantly, it involves self-awareness, knowing our own blind spots, and empathy, the ability to see the world from someone else's point of view. And that leaves us with one final, absolutely massive question for the future. As AI continues to get smarter and smarter, mastering tasks we once thought only humans could do, is this deep, embodied, value-driven process of understanding going to be the final frontier, the last thing that truly separates us from the machines we create? That's something we're all going to have to think about. Thanks for joining me on this exploration.